Rami Yaka, shalom.
Shalom.
So you were here for the 7th conference organized by the AFIRNe.
Yeah.
Can you describe us your work
Yeah.
in few words?
So I'm working on the things that happens in the brain following withdrawal from the drug. So drug addicts usually, when they withdraw from the drug, 90% of them during the first year will go to relapse. In other words, they will reuse the drug. So what we're doing is looking at the changes in the brain that responsible for the trigger to relapse. And we found that there is a lot of engagement of the learning and memory machinery, that the drugs hijack the system for their own benefit. And when you understand how this interaction works, then the idea is to prevent the changes and to prevent relapse. So if we put it in a more simple words, what we found is that one of the major things that causes relapse is the drug-associated cues. When you see a cigarette or when you see a tobacco store, then it triggers a sensitized response that makes you to reuse it. And we found a molecule that can dissociate the memory of the drug with the cue. In other words, now you go to a kiosk, you see a tobacco store, you don't relate it to anything. You just continue to walk and it's not trigger any relapse. So this is one of the directions that we are working on. We also look at global changes in other areas that relate to this change during withdrawal, because the idea is that also found that the longer time you wait after withdrawal, the more chances is to relapse. So something happens in your brain, although you are clean, that makes you sensitized to reuse the drug. And we are trying to see what these changes and trying to understand and prevent these changes to occur to prevent relapse. That's it.
What I understand is that you provided some information about the ZIP, something.
So the specific thing that I just talked in this lecture is a small peptide that inhibits a protein which is responsible for the electrical change. And by inhibiting this, you inhibit the memory, or you erase the memory that relate to the previous experience with the drug.
So the question is, how do you bring this zip into the brain?
Oh, that's a very challenging question. So we are in the School of Pharmacy. We have experts in drug delivery. So they have nanoparticles. We know how to fill the nanoparticles with this peptide. And now we're working on targeting first. We're crossing the blood-brain barrier, which is the first barrier, and then now we're working on how to target it to a specific place in the origin in the brain, in order to be specifically erase the memory in this brain also, or in this subregion also, because it's the same mechanism everywhere in the brain. So you don't want to erase all the memories. You want to specifically erase the one that relate to cocaine, and that's what we try to develop.
Thanks a lot.
Thank you.
Bye.